Okay, today we're going to spend another day working on this formula for finding the derivative of the function. We didn't get to cubic functions, so we'll take a look at some cubed functions today. And then I want to take a look at this other set of directions on page 25, which we'll do next, okay? All right, so let's start with example 3. I think once I get this going for you, I'll have you try to finish it and answer it. All right, so remember the first thing we need to do is evaluate the function with x plus h. It's almost like a little composite function. Then once we have that, we'll be able to just set up our limit to find the derivative for the function. Okay? All right, so here we go. What does f of x plus h look like on this problem? We have one spot to substitute it in at, so 2 minus the quantity x plus h cubed. Okay, so to cube this, we could get fancy and get the binomial theorem out. When the exponents get higher than 3, I would definitely encourage you to do that. But I think to the third power, we don't have to over complicate things here. All right, so what I mean by that, here, let me show you what, remember, the big picture, when we cube something, we don't just cube x and cube h. We really have this going on. You don't have to write this down yet. I'm just going to, unless you think this will help you. We have to expand it and multiply this, right? Now remember, we already know what x plus h squared is. All right, any two of these. We just did it on number 2 and multiple problems from your practice problem on the other side. X plus h squared is always equal to this. So why don't we just use that to our advantage and then multiply it by x plus h one more time? Does that make sense? So what I mean by that is this right here, I could say is x squared plus 2xh plus h squared, and then I'm just going to now bring the x plus h down and just distribute that, okay? So that's what I'm going to write up here. So we have 2 minus x plus h, and again, I'm stealing the x plus h squared from the math we already did. X squared plus 2xh plus h squared. Okay? All right, now to finish this product, I'm going to take the x, I'm going to distribute that through, and then I'm going to distribute the h through. Okay? And then I got to subtract it all too, so I'll be careful with the sign here. So I've got a lot of terms. I'm going to move down here to give me some room. 2 minus. So here I get x cubed. X times 2xh is going to be 2x squared h, and it's positive. Just a lot of terms on this one when it goes to the third power, but it's not too complicated. X times h squared. Okay, so that's what we get when we distribute x through. So let's now take this h and distribute that through. So here I get hx squared, or maybe if I want x squared first, since I did x squared first here, I'm going to do that. So plus x squared h. Here's going to be 2x h squared. And here I have h times h cubed. Okay, I do have some like terms, right? The x squared h and the x squared h, I'm going to combine those, and then these as well, the x h squared. And let's distribute this negative now in this step. Okay, so we have 2 minus x cubed. This 2 plus this 1 is 3, but it's going to be minus, so minus 3x squared h. Looks like I have 3 again of these xh squareds, right? 1 and 2 of them, so that's 3, but I'm subtracting it. And then the h cubed, subtracted. Okay, so things kind of already simplified down a little bit with some of these combining like terms. Now we have the function with x plus h. Took a while, but there it is. Now we can set up our limit and get the derivative for the function. Okay. All right, so the derivative f prime of x is equal to the limit as h approaches 0 of function we just created minus f of x over h. So the function we just created, it's dropping it down here. If you want to put the 2 last, fine, it doesn't really matter. Okay, minus f of x, which was just 2 minus x cubed, all over h. Okay, again, some things are going to start simplifying. So 2 minus this 2, gone. This negative x cubed, well, here I have a minus negative, which means it's plus, so those are going to be gone. And we're left with this now. Okay. Now I do notice that all of these have at least an h in common, so I'm going to try to do 2 steps in one because we're running out of space here. So the limit as h approaches 0, I'm going to take out this h right now. Okay, so GCF style, I'm going to put the h out front, and I'm left with negative 3x squared minus 3xh minus h squared. Okay, when finding limits by hand, we can throw that in and evaluate as long as it's defined. It's not defined for h right now, at 0, I'm sorry, because we'd be undefined. But by factoring out that h, it allowed me to reduce this h now, and now we can. The substitution will work. I don't think I need to rewrite this whole limit for you to see that, because now 0 is going to go in here and here, and let's go ahead and use the direct substitution to evaluate this limit now. So negative 3x squared minus 3x times 0 minus 0 squared. Okay, so that'll be 0, that'll be 0, so it's just negative 3x squared. So my derivative function, the answer to this problem, the first part, is negative 3x squared. Remember, another phrase for derivative is the slope of the tangent line. And so the slope of the tangent line changes for these curve problems, like we did on 2 when I was showing you here this parabola. Right? The slope of this tangent line is different than the slope of this tangent line at 1. It's different for x equals 2. Keeps changing. So what we just found is a formula that we can use for any x value. It right away gives us the slope of the tangent line at that spot. All right, so we just did step 1. We found the derivative of the function. Then we're going to write the equation of the tangent line at the given point. So my given point is 1, 1. So now to find, sorry, I'm zoomed in too much, can't see everything. So to find the slope at this spot, I want to use this x value of 1. Okay, so f prime now at an x value of 1 will be negative 3 times 1 squared, which gives us negative 3. So that is the slope of the tangent line at an x value of 1. Okay, so now we can use the point slope form to write the equation of the line like we've been doing on all of these. Okay, so y minus my y coordinate, which is 1, equals m times x minus the x coordinate. And like I said before, I'm okay with you leaving it in point slope form. If you have a multiple choice problem and solve for y, then distribute and add the 1. Okay. Okay, let's have you get one of these going. I'll give you some feedback in the notes here. How about this practice problem number 4? You might kind of need some of the space over here on number 3 as well, because this one takes up some space. But remember, you can use what we know x squared is to your advantage. If you did number 2 over the weekend, you have it right here. X plus h squared is what? Right here. Here it is. So then to cube it, you just need to do it one more time. But we just did it on the previous page, so you can use that too. X plus h to the 3rd power will be the same every time. Okay? All right, so let's go ahead and try that on your own. I'll give you some feedback on 4 here in just a moment. Just a quick little reminder too on the binomial theorem if this helps you. Remember, there's a pattern to this. Whatever term is first, and you raise it to this power, you take that and raise it to that power, then maybe leave room for the coefficient, but it's always x to the 3rd. And then this keeps going down. This is h to the 0 to start. So then we have x squared, h to the 1st, right? Plus Now this goes down to x to the first, h squared. And then now we're down to x to the 0 and h to the third power. Okay, so the binomial theorem will get you there right away. You just got to remember the coefficients. I showed you a few ways before how to do that with combinations or Pascal's triangle, or just remember it's always going to be 1, 3, 3, 1 for this one. And you got your x plus h cubed just like that. Okay, even x plus h squared does the same thing, right? X squared, x to the first, x to the 0 follows the binomial expansion. All right, so whatever approach you want to take, you want to use the binomial theorem and get that right away. Here's x plus h cubed. Or maybe you want to take the x plus h squared and distribute that. And you might get this step in between. One way or the other, we need to get to this step for x plus h cubed. All right, then plus 3 times that, and then plus the 2. Okay, so there's the f of x plus h. It's a lot of terms. Minus f of x, and then look, some things start to cancel out right now. X cubed, gone. 3x is gone. So is the 2. So then it cleans up like this. And I took the h out in the same step, just so that we kind of save some writing. Everything I had left, I noticed had an h in it. Here, 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 and here. So if we factor that out, now substitution will work. So I did the substitution right here. I put in 0 in these spots, here and here. Okay, so that gives us 3x squared plus 3 when we simplify that. So that's my derivative. Okay, then it says at the point 0, what's the slope at 0? So I throw in 0 right here and evaluate it. I get a slope of 3. And now I can go ahead and finish the equation of the line for that spot. Okay, let's look at page 25, this last example. I'm going to walk you through number 2, and we'll wrap this up. Okay, so find the derivative of the function. This one's just different because it says find the tangent slope at these different spots. All right, so the derivative will be, we need to find f of x plus h first. So we have 2 times x plus h squared plus 5 times x plus h. Okay. Squaring x plus h, we have that from before. It's x squared plus 2 times xh plus h squared. Okay, now it's just time to distribute this 5 and distribute the 2. All right. I mean, for the most part, we kind of know how to find the derivative now. So to keep this video under 15 minutes, I'm going to pause and let you try to simplify this, set up the derivative, and then when you're done, see if you can find these different answers to these, the slopes for those different x values. Okay, go ahead and give it a shot. Okay, once we distribute the 2, there's really no like terms to be combined. We just have this entire function for x plus h minus f of x. So all these x terms cancel out. And here I noticed again an h was in common these 3. So I factored out that h, simplified it, and now substitution will work for finding that limit, or table method if you prefer in your calculator. Okay, so 4x plus 5 is the derivative. That explains the instantaneous rate of change or slope of the tangent line for any x. So here I plugged in these x values to get the derivative at those specific x values. So we get 1, 5, and 13. Okay.